Using the lab pad is an important way to get the most out of this simulation. Is this the first time you've played a Labster simulation? Do you want to know why you are here on Asticos 4? Alright, then let's dive right into today's mission.
Okay.
What does high biodiversity mean?
Many species.
Yes. When you are ready, click on the image of the Sandunan Desert. There we will talk to Francisco. Click on the image of...
Hello, I am Francisco, and I am an ecologist here on Asticos 4. Welcome to the hot Sandunan Desert. I hope you brought your sunscreen. Today I am looking at the biodiversity found here in the desert.
I, Dr. One, will be your lab assistant for today. Maybe you would be up for helping Francisco? If you could take on
Yes, that would be great.
Did you know there's a well-known correlation between the Click on the screen.
Yes, on Earth you typically...
Let's find out. We can investigate this by sampling and comparing the biodiversity and now go back to the lab. When you are...
Teleporting again. Okay.
Before you can go out to sample the biodiversity, you will have to plan your collection. As any ecologist know, you will have to make compromises to achieve greatness, or at least prioritize to get useful data. First you will get a super short introduction of each method you will be using today: the camera trap, the pitfall trap, and the quadrat. Click on the quadrat. This is a quadrat. A quadrat is often used with plants or other sessile organisms to limit the workload. It is placed on the ground. Click on the pitfall trap. A pitfall trap is a hole you... Click on the camera trap. The camera trap is as a single ecologist sampling an area, you only have a certain number of person-hours and resources to set. Go to Workbench 2 and use the computer.
Her voice annoys me a little bit.
Use the screen to prioritize your sampling. Click Use Setup when you are finished. Click on the image of the Sandunan Desert to go there.
Okay, let's go to the desert. Teleporting again.
Here in the Sandunan Desert you will collect data about the diversity of photoautotrophs. Proceed. Click one of the quadrat placeholders in the field.
Okay, let's go.
Click on the quadrat and then perform your sampling.
Right next to the rock, quadrat. And I picked up the sensor.
Well done. You are sampling sessile photosynthesizing organisms using the selected prioritization. Which is the best way to sample sessile organisms with quadrats?
Randomly.
Well done. With limited resources, we should choose random locations. What determines the optimal number of quadrats?
The density of organisms, I believe.
Well done. Nice. We're finished with the quadrats and the...
Okay, teleporting again.
This is the second location, which is a mountainous area with low sparse vegetation.
Okay.
Here you will sample by hand for small and highly mobile creatures, using pitfall traps. When setting up traps, don't forget to check them regularly.
Pretty boring, but
Place the pitfall trap in the ground.
Okay, so you've got a shovel. Dig with the shovel. Dug a hole, put the shovel down, pick up the bucket, pull the trap, and put that
Now we need to wait a while to see if we catch anything.
Continue.
It's been 5 hours. Let's have a look in the pitfall trap. Click on the pitfall trap and collect the creature inside. Click to pick up the creature.
I don't know if I should be putting my hands in on a random creature.
Place the creature in the carrying cage.
That's
wow, look at this cute critter we captured. We will have to use a dichotomous key to identify what type of organisms are best sampled with pitfall traps.
Mobile.
That is correct. How often should you check a pitfall trap?
We did every 5 hours, but I guess it depends on the number of organisms? The density?
Awesome. Don't
Okay.
forget to... Now we are done in the shrubbery. So now you have reached the end game. Well done. Not many make it this far.
Put the
Here you will
camera
collect
down.
data on larger heterotrophic organisms from the highest elevation you will see today.
We're at
We are in a forest
61%
consisting of large
progress.
photoautotrophs, which never drop their canopy. Now that the camera is set up, we can return in a few days to see if we have any It's been 4 days since we set up the camera trap. Let's take it down to see if we caught anything. We will check. Take the camera back down. Well done. Let's have a look at the images back at the lab.
Okay.
You will now get to use a dichotomous key to identify one of the... Okay, are you ready to identify the organism you caught with the pitfall trap? Go ahead, pick it up. It won't bite. Identify the organism caught using the pitfall trap.
Okay. So you got the options. So I'm assuming... Okay, it's got a mouth. 6 legs. 3... I think they're eyes. It has got a rainbow tinge next to its
Well
mouth.
done. You identified a slobster. If you want, you can read more about it on the screen. Don't forget to put the slobster back in the cage.
I don't really care about it because it
Now
doesn't
that you
exist
sampled
in
3
real life.
areas and identified a slobster, let's see how we can easily quantify the data collect. Go to Workbench 1. Okay, so the simplest way to quantify your findings is by determining the biodiversity index. To calculate it, you need to count the number of different organism types you found in the area, as well as the total number of organisms found in the area. Based on your sampling, you can extrapolate how many organisms, and how many different kinds of them are present in the area. The biodiversity index is the number of different... Click on the display above the word. Look at the poster on the wall. Which of the 2 areas has greater biodiversity? You can have a closer look at the poster by clicking View Image. Amazing. Well,
Okay.
click the different things. Click on the quadrat. What type of organisms are best sampled with quadrats?
Sessile terrestrial.
Nice. You click on the pitfall trap. Where would you place a pitfall trap?
Wherever there are small animals, terrestrial.
Nice. You click on the camera trap. Which of the following places would not be suitable for a camera trap?
In a stream with aquatic organisms.
Well done. You understand. Why can't you compare data collected with different sampling methods? Well done. Each method
Okay.
was designed for a specific purpose. Because you chose low priority for the quadrat, you chose medium priority for pitfall traps. You found a trend. I wonder if you did enough to actually verify this trend? You found a few highly mobile different organisms in the sand dune and desert, and even more different ones in the air. Wow, you sure like your cameras. Well done. By choosing high priority, you found a trend showing a few large mobile organisms in the sand dune and desert. Quite a high variety in the area with low sessile photosynthesizing organisms. So, is the altitudinal gradient of biodiversity on Astacos 4 similar to that on Earth? If you tell me, I will let Francisco know what you found. Based on your sampling, was the biodiversity on Astacos 4 highest at an intermediate altitude? Yes. Nicely done. Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress.
Fantastic.
Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.
And exit.